Okay, for starters, I want to just fill this chart out one more time. And like I said, my old one's getting kind of, and I think this would just be kind of a good thing to recall real quick. The sign of 0 is 0, which is the square root of 0 over 2. The sign of 30 is a half, which is the same as the square root of 1 over 2. The sign of 45 is the square root of 2 over 2. And then the square root of 3 over 2. And then the sign of 90 is 1, which is the square root of 4 over 2. Cosine is the reverse. So cosine of 0 is 1, which is root 4 over 2. Cosine of pi over 6 is root 3 over 2. This is root 2 over 2. Cosine of pi over 3, or 60, is 1/2, which is root 1 over 2. And then cosine of 90 is 0, which is root 0 over 2. And then finally, tangent is sine over cosine. So tangent here is 0 over 1, which is 1. Tangent of 30 is root 1 over root 3, or you could just say 1 over root 3, which if you rationalize is the same as root 3 over 3. For tangent 45, that's this over this, root 2 over root 2. And that's 1. This guy is root 3 over root 1, or just root 3 over 1, which is root 3. And then 1 over 0 is undefined at 90 degrees. So that's my little chart one more time. And also for this section, we're going to need to remember my sign chart of what quadrant has what sign for sine, cosine, and tangent. So all you have to remember for this is the x and the cosine travel together, and the y and the sine travel together. Here's my x, here's my y. So for starters, if sine goes with the y and y up here is positive, then sine in the first two quadrants is positive. That's 1, 2, 3, 4. And then sine is negative downstairs here, because y is negative down there. So now cosine, since cosine and x go together, x is positive on the right side. So it's going to be positive on the right, and then negative on the left. And then last for tangent, tangent is equal to sine over cosine. So that's plus over plus, which is plus. Tangent here is plus over minus, which is negative. And then here, tangent is negative over negative, which actually makes a plus. And then this is negative over positive, which is negative. So that's my chart to kind of recall, what is positive or negative when. And these are my 5 special angles. Obviously, there's tangent of 20 degrees, cosine of 80 degrees. There's lots of other angles besides these 5. But these 5 can get us a long way. So that's why we kind of focus on these 5 to start out. Okay, so I want to solve kind of a basic trig equation. How are we doing so far? I want to just start out with kind of a basic trig equation that looks like this. There's really no solving to do here. No algebra to do. But I do need to kind of, there's a trick here about getting all the answers that I need. Typically, we assume, first of all, we want all answers on this interval. That means that we want all the answers in one full cycle. Sometimes it's written separate, it's written differently, but if you don't see any sort of like qualification, then this is what you assume they want, all the answers between 0 and 2 pi. So without having to do any algebra at all, let's go straight to my chart. What angle makes sine 1/2? What angle up here makes sine 1/2? Here's 1/2, here's sine. That looks like 30 degrees, or you could say pi over 6 radians. I kind of started writing radians here, but we could do degrees. I'll say 0 degrees. We'll write it in both. Either one of those. It looks like 30 degrees is a possible answer. 30 degrees right in here, or pi over 6 radians would make sine equal to 1/2, which is correct, but it's only half of the answer. And what you have to recall is sine can be a positive number in the first quadrant, where 30 degrees would be, also in the second quadrant, okay? So what you have to do is draw a little picture and just kind of remind yourself that there's probably 2 possible answers. One is right here. This is where sine is positive, but also sine is positive over here. So if you take 30 degrees as a reference angle right here, that is the angle of actually 150, since this whole thing is 180. And so the 2 angles that would work here would be 30 degrees or 150 degrees. If you were to take sine of 30, you would get that positive 1/2, because sine's positive. The sine of 30 is 1/2. If you put in 150 here, the sine of 150 is the same as the sine of 30, which is the reference angle. This is my reference angle. And since sine is positive right here, you could say sine of 150, just to check yourself, is equal to positive sine of 30, which is positive 1/2. So this is my answer in degrees. I could also give an answer in radians. 30 was pi over 6. A way to kind of remember what the radians would be is take the 30 out over 180, and that's 1/6. So this is 1/6 pi over 6. And then for the 150, do the same thing. 150 over 180 reduces to 5 over 6. So we could say, or 5 over 6 pi, 5/6 pi. So those are my 2 answers here for a sine theta equals 1/2. Pi over 6 or 5 pi over 6, 30 or 150. How are we doing with this? The easy part is to say, hey, look at my table. You know, sine 30 is 1/2. You know, no problem. The hard part is to remember that there's probably more than one answer. There's probably more than one answer. And I said, you know, we had this 0 to 2 pi. That just means one full lap around the circle. That's kind of the most typical ask that you'll see when you're solving a trigonometric equation, is that you're looking for all the answers in one full cycle. Okay. I'm going to take this off. Let's try this one. This one we have to do some algebra with first. So I'm going to start by taking away 2 from both sides, just like you know, the good old days in algebra 1. Cross that out. 3 roots of 2 cosine theta equals -3. And then to get cosine by itself, we're going to divide both sides by 3 roots of 2. the goal here right now is to get cosine by itself. So I'm going to divide by the 3, divide by the root 2. Those cancel out. And I get cosine theta is negative 3 over 3 root 2. And what can cancel out here? 3. Good. This is negative 1 over root 2, just like that. And then this does not really match anything in my list currently, but it kind of looks like this. What you have to do sometimes is rationalize to get the square root out of the bottom, and you do that by multiplying. This is called a well-chosen one. It's 1 because it's root 2 over itself. And it's also well chosen because it helps you out with what your problem is. You get root 2 times root 2, that makes 2 on the bottom. And then negative 1 times root 2 is negative root 2. So what we've got going for us now is cosine theta is negative root 2 over 2. That's my real equation that we're going to deal with. So again, we're looking for 2 answers. And I'm assuming because there's nothing specified that it's in that one full lap, 0 to 360 or 0 to 2 pi radians. So I want to think about when cosine is negative. Cosine was negative in the second quadrant and in the third quadrant. These 2 quadrants right here. That's where the x is negative. Cosine follows the x. What about root 2 over 2? If you look at your chart here, here's cosine. Here's root 2 over 2. That was 45 degrees, or you could have also said pi over 4 radians. So we're going to draw a picture. So cosine's negative in the second and third quadrant. The reference angle was 45 degrees. We'll do this in degrees. Just like that. And this is 180. This is 90, 270, 0, or 360. What's that? Why the angles are like this? Okay. So one full lap is 360. So you start at 0. Then you go 90. That's a quarter. 180 is a half. 270 is 3/4, and then 360 is all the way around. You good with that? Okay. These are my 2 angles that are going to be my answers. They both have a 45-degree reference angle in the second and third quadrant. And so if you go here to there and end on that line, that's 90 plus another 45, which is 135. You could also say 180 minus 45, which either way is 135 degrees. So one answer is 135. I'm going to say or. And another answer would be there, which is 180 plus 45, because we go 45 plus 180. So that would be 225. And so that is my answer in degrees. You also could have said, what about 135 over 180? What's that? Well, that's going to be 3/4. So theta could have been 3/4 pi radians. Or what about 225? That would reduce to be 5/4. You could say 5/4 pi. So those are my answers. These are the same. These are the same. So this is like Fahrenheit and Celsius. You know, the same temperature can be expressed as 2 different things. 135 degrees, 3/4 pi radians, or 225 degrees, 5/4 pi radians. Those are the same. But either way, we got our 2 answers. How are you guys feeling about this? Good. Taryn, you good? Okay. Evelyn, how are you? Good. You all right? You know what's going on? Yeah. Kind of? No, you didn't. Okay. Well, let's mix this up a bit. because this is too easy. Kai, how about you? You know what's going on? Good. All right, let's get this. Let's get a little crazier here because I need some excitement. Let's see. Where'd my problem go? How about this? Sine of 3 theta equals -1. All righty. So we need to think. So when you have something in here that's not just a 1x or 1 theta, first of all, just ignore it. Just ignore it. Pretend like it's just not an issue, and just think about, when is sine equal to -1? Let's look at my chart. Well, we had sine was equal to +1 at 90 degrees right here. This was 90. And this is 180 and 270. When you're on the actual axes themselves, here or here, 0, 90, 180, 270, for sine and cosine, they can basically only be +1, -1, or 0. So like, why is sine of 90 +1? It's because right here at 90, you go from a positive number to a positive. If you go from one positive to another positive, what did you skip over? You skipped over a positive. What about when you go from the second to the third quadrant at 180? Watch this. If sine is positive and then transitions to be negative, what did you have to skip over to go from a positive to a negative? Come on, people. What do you have to skip over from a positive to a negative? Yeah. Well, yeah, you had to skip over the x-axis, but if you go from positive numbers to negative numbers, say you're on a number line, what do you have to skip over? 0. So sine of 180 is 0. And then downstairs, what we wanted, I wanted to know when sine equal to -1. That was my question. Down here, watch this. If you go from negative to negative and you cross over the y-axis right here, what kind of number, if you had to pick between +1, -1, and 0, which of those numbers seems most likely you're going to skip over if you go from a negative to another negative? -1. Yeah, if you go from if you're on a number line and you start on a negative and you end on a negative, then you skipped over all negatives. So sine of 270 is -1. So let's just, I'm going to say, we'll do this note. Sine of 270 is -1. Okay. So if sine of 270 is -1, then what's 270? Where does the 270, where would you swap out the 270 here? The 270 is what's in the parentheses. So 3 theta is equal to 270. If you want to know what goes in here to make -1, it's 270. So that means 3 theta has to be equal to 270. Now, if you want to solve for theta, you just divide by 3. 90 degrees. Or pi/2 radians. How you guys doing with that? That's not too bad. If you see something inside the parentheses that is not just a 1x or 1 theta, just ignore it. Just ignore it until the very last step. And at the very last step, when you know that sine of 270 equals -1, and this sine of something equals -1, then your something has to be that. Okay. Let's try another one, kind of the same, in the same spirit of things. Now this one's a little crazier because it's got cotangent. Okay. And I'm going to say recall cotangent of theta is equal to 1 over tangent. Okay. So what you can do here, that's cotangent over 1 equals 1 over tangent. You can write this over 1 and this over 1. And you can take the reciprocal of both sides. Or as some of my nuttier cats say, the reciprocal. None of you guys would say that though, would you? Haley, did you say reciprocal or reciprocal? Howdy. Huh? Okay, I'm just checking. So if you flip one side, you can flip the other side. Cotangent, 1 over cotangent, 2 theta over 3 equals negative 1 over root 3. Okay, well, cool. And it turns out even cotangent is 1 over tangent, and 1 over cotangent is tangent. So now we've got something I know how to work with, something in my table. So that is how I kind of get to tangent. Since I don't have cotangent in my table, I've got tangent now. And let's just look at my options. 1 over root 3 is what I'm looking for. Do you see that any place? Here's tangent. I see 1 over root 3 right there. It got rationalized to root 3, just root 3 over 3. But either way, that goes with 30 degrees. 30 degrees. That's my reference angle here. So I'm going to say, well, ignore that right now, that 2/3 theta. We don't need that. But I know my reference angle is 30 degrees. I'm just going to write that down now. And we're going to draw it. And it's negative. So where is tangent negative? Tangent's negative in the second quadrant. It's also negative in the fourth quadrant. So we got a 30-degree reference angle in the second quadrant and the fourth quadrant to wrangle with here. So here's 30 right there. It's a reference angle of 30. And then that's the second quadrant. Then we got the fourth quadrant down here. That's going to have 30 as well. Reference angle is 30. So now all we have to do is figure out what is this angle. Well, that's 180. So if you knock off 30 from 180, you're at 150. And then all the way around, since this is 360, if you knock 30 back from 360, you got 330. So now we know that tangent 150, tangent 330 is this. The problem is we don't have just a theta in here. We've got 2/3 theta. So we know 2/3 theta has to equal 150. And 2/3 theta equals 330. So this is how we ultimately solve for my theta, is just set whatever's inside the tangent equal to 150 and also the 330. And the last thing to do is solve, multiply both sides by 3 over 2. I'm running out of space here, sorry about that. But theta equals, what's 3 over 2 times 150? That's 225. That's one answer. And 330 times 3 over 2, that's going to be, well, half of 330 is 165. So add that to 380 and you get 495. And anybody know why I'm not quite comfortable with 495? Can anybody guess? Yeah. You bet. It's more than 360. I don't like that. I don't like that. Especially if they said, find me an angle between 0 and 360. So what you can do at 495 is you can subtract 360 off of it and get you 135. Is that right? Because this would be a coterminal angle. This would be, if you take off 360, you get 135. So this and this are the same. They're coterminal. So I'm going to say 225 and 135 are going to be my answers here. How we doing? Okay. Oh, man. You know, I'm gonna backtrack on what I just said, because I don't like numbers that are bigger than 360, but I just forgot that we had 2/3 out here, and if you put 135 times 2/3, you're going to get 90. And I'm going to tell you that right off the bat, the tangent 90 is not -1/√3. So even though these are coterminal, because if you take off 360, basically what you're doing is you're changing the quadrant. So I'm going to either stick with 495 or trash it, because if I want an answer between 0 and 360, this ain't going to work. And so I think this is the only answer I would write down. That one's kind of some tricky business. It is coterminal. 495 is coterminal with 135. But when you start multiplying 495 times 2/3 versus this times 2/3, they come out to be in different quadrants. So that's why I think I would be careful there by just knocking off a lap. How are we feeling about this? Should we get even freakier with these problems, or should I tone it down a little bit? I'd vote for freakier. It is Monday morning. Why not? All righty. Lost my place. Let me find it again. All right, we'll tone it down just a little bit here. But I do want to do another one where we have a function that is not just a sine, cosine, or tangent. And so we've got a secant here. Don't forget, secant is 1/cosine. So I'm going to take away 6. And we get 4 times secant x equals -8. Divide by 4. You get -2. And now, like I said, recall secant is 1/cosine. And also cosine is 1/secant. So what you can do is write these both over 1 and flip them both. Take the, as Haley said, the reciprocal. It's not what you said. Is that what I said? Fair enough. Fair enough. Okay. So 1/secant is cosine. So this is really something, I can write this as cosine by just taking the reciprocal. Somebody answered that for me. It's around the corner. Thank you, sir. So when is cosine negative? It's negative in the third quadrant and in the second quadrant. Everything all right? Is that for you? Huh? If I was here? Did you answer him? All right, whatever. If it's really important, they'll send somebody up here. That's kind of how I feel about it. If it's really important, I'll get more than a phone call. All right, cosine is negative. When is the cosine negative? Cosine goes with the x. So cosine's negative in the second quadrant and the third quadrant. That's what I'm going to kind of bank on. Also, what about 1/2? Look at my chart. Cosine at 60 degrees is equal to 1/2. So my reference angle is 60. I'm going to say reference angle 60 in Q2, Q3. That's kind of where I'm headed here. So let's look at Q2 and Q3. Here's Q2, Q3. 60 is going to be like right there and right here. So this angle, if you back 180 back by 60, you're going to have 120. And then if you go all the way out here, that's going to be 180 plus 60. That's going to be 240. So x is going to be 120 or 240. And let's do that in radians too while we're here, just for giggles. So we're going to take 120 over 180 and we get 2/3. So x is going to be 2/3 pi radians, or what about 240 over 180? That's going to be 60 reduces, this reduces by 60, so it's going to be 4/3. So 4/3 pi or 2/3 pi if you do that in radians. I think I'm almost ready to start the ones with squares in them. Something squared. Can you guys handle that? I see Corson. You better be shaking your head. Yes. All right. We'll start it out with some slow pitch. Start out with some slow pitch here. All right, what's first? Add 1 to both sides. Sounds like somebody took algebra 1 and made an A. Well, you learned something at least. What's next? Divide by 2. Just like that. Sine squared equals 1/2. And now to get rid of that square, now things are getting a little scary. We're going to take a square root of both sides, right? So the sine is going to be square root of 1 over the square root of 2, right? What else? When I take a square root, there's always the chance of having a plus or a minus. So I'm going to just sneak in a plus or a minus in there, because if you take the square root of 9, it could be 3 or -3. The square root of 25 could be +5 or -5. And likewise, the square root of 1/2 could be plus or minus √1 over √2. And that is actually plus or minus, square root of 1 is easy. That's just 1 over √2. And, you know, if I look at my table, I don't see a √1 over √2, but I do see this. So let's just rationalize my denominator here while we're at it. I think we saw something like this earlier. Multiply by that well-chosen 1, √2 over √2. And this is plus or minus. Downstairs, we got 2. 1 times √2 is this. So I'm going to just recopy it. Sine of theta is plus or minus √2 over 2. So that's what we've got to deal with now to get my answers. And now √2 over 2, I can see now sine √2 over 2, that's 45 degrees. And the question is, what quadrant am I in? Any guesses? Huh? Quadrant 1, what's sign in quadrant 1? It looks like it's positive. Any other quadrants besides quadrant 1? Huh? Also positive in quadrant 2, 1 and 2 for sure. Any others? 3, yeah, it's plus or minus. This one's in every dang quadrant there is. Every dang quadrant, 1, 2, 3, and 4. Because we got positive, and we also got negative. This one maybe I'll check on my calculator. But first, let's make my reference angle. There's a 45 right there. There's a 45. There's a 45. There's a 45. Also, we got 4 reference angles. Let me just fill this in. 90, 180, 270. That's 0 or 360. So this one's easy. That's 45. If I go around to this one, this is 180 minus 45, so that's 135. And then if I go around all the way to here, this is 180 plus 45, that's 225. And then last, all the way around to this last one, that's 270 plus 45, or 360 minus 45, 315. So those are my 4 answers this time. That one's a little wild and crazy. Let's just check it. So that was my original equation. Let's just check this. Make sure you're in degrees, because I answered mine in degrees. I'm going to push mode, go down to degrees, hit enter, so I'm in degrees. And it says 2 times sine squared, so I'll do sine. How about 45 first? Sine squared, and then minus 1. That's kind of what I was dealing with. Sure enough, that's 0. If you push second enter right here, second enter, it brings up what you just typed. So I can go in and type in 130 and insert a 5 there. See if that one works. Yep, that one works. Second enter again. 225 this time. That one works. And then second enter one last time, 315. That one works also. So all 4 of those are our answers, so we checked them. Charlotte, how you doing? Do you do this? Can you do this? Okay. Oh, let's get another one. I'm kind of debating whether we should do one with factory today or save it for Thursday. I kind of feel like we should do it today. We'll do some more like it, but I think I'm just going to at least introduce this to you, because it is, at first it seems really weird, and then after a while it's not as weird as you think. Let me find my place here. 2 cosine squared. Okay. Now, factoring something that, it just feels like it never goes away. And that's pretty much because factoring never goes away. It just sticks with you forever. And so I'm looking at this equation, and I see it's got cosine in 2 different spots, and one of them's got a square, and that just looks awful. So I'm going to also notice that this is in the same form as a quadratic equation. It just isn't quadratic because it's got cosine. I'm going to come over to the side and say, okay, let's pretend that we have 2x squared plus x minus 1 equals 0. Okay, this is like 2x squared plus x minus 1. You see 2x squared plus x minus 1? That's kind of the same sort of thing. And if I did have this, and this was last fall when we were just learning how to do quadratics, you would have factored this. Would have said 2x times 1x makes 2x squared. And then I would have asked, what two numbers multiply to be -1? And it's going to be +1 and -1. And you would have had to factor it like this, because remember, 2x times 1x is 2x squared. That's the first terms. The outer terms are 2x. The inner terms are -1x, which 2x and -1x makes you a 1x. And then -1 and +1 makes multiplies to be -1. So, this is kind of over on the side. What it's telling you is if you replace the x with cosine, you could factor this the exact same way. You could say, this is going to be 2, not x, 2 cosine theta -1. And this is going to be cosine +1. So basically factor like a quadratic. That's something that if I didn't tell you, if you're looking at this from the first time, you probably never figure it out. And that's fine. That's normal. This is kind of pulling something, out of the toolbox you haven't thought about in a while. But anyway, once you see that you can factor this like a quadratic, now it's time to solve it. And if this equals 0, or if this equals 0, 0 times cosine theta +1 is 0. 0 times 2 cosine minus 0 times anything is 0. So basically, if any of these make 0, 0, or this, then you've got answers. So you've got to take both of these, set this equal to 0, set this equal to 0. Now we're going to go back to my Algebra 1 days. What'd you say? That's what I said. Algebra 1. Back in the good old days in junior high, at the peak, when it was cool not to wear deodorant. Yeah, you know what I'm talking about. So cosine is going to be +1/2 there. And down here, you're going to take away your 1. And cosine is going to be -1. So both of these are going to give you answers. We got to figure out what those answers are. So we'll start with cosine of 1/2. Cosine equals 1/2. Cosine is positive here and here. So in quadrant 1 and 4, 1/2 had a reference angle right here. Cosine is 1/2 at 60 degrees. So we're going to have a 60-degree reference angle in the first and fourth quadrant. Let's draw that before I forget it. There's 60. There's 60. This is Q1, Q4. So there's 60. One angle is 60. And then the other one's going to be, this is 360. So if you back it off, if you back it off 60, you get 300. So these are two answers. And then when's cosine equal to -1? Let's look at my chart one more time. As we go from plus to minus, this cosine 90 should be 0 because a plus to a minus should cross over 0. Sure enough, cosine of 90 was 0. If I go from a minus to a minus, that should be a -1 right at 180. If you go from minus to plus, cosine of 270 should be 0. Then a plus to a plus, that should be 1. So I said, when was cosine equal to -1? It's going to happen right here at 180, before we go from minus to minus. So this guy over here is going to be 180. So these are my three answers this time: 60, 300, 180. They all should work. Should I check them? You check them, or you believe me? We'll check them. We had 2 cosine, 2 parenthesis cosine. We'll start with 180 squared, and then plus cosine 180 minus 1, does that equal to 0? It does. If you hit second enter, we'll check 300 next. 300. That also would be correctly 0. Then was the last one, 60. Second enter, bring that all up. Let's do 0, 60. That's also 0 also. I put a 0 in there to just save the 3 places, but anyway, whatever. Let's see here. How did I do one more like kind of similar, and then we'll let you work on this for a while. How's that sound? Okay. Sounds good. Let's do let's do this one. This one is also one that is squared. It also requires factoring, but it only has 2 terms instead of 1, or instead of 3. So this is not going to kind of factor in the reverse FOIL sense we did a minute ago. This is actually more simple. What could you factor out of 2 cosine squared and cosine? My goal is to get rid of the squared, by the way, if possible. What comes out of both of those? 2 cosine squared and cosine. What comes out of each of those? Rachel, how about you? Cosine. Good. Good. So we're going to take cosine out. And then left over is going to be a 2 cosine. And then left over here is going to be plus 1. And so now you're just going to say, when does this cosine theta equal 0? Or when does 2 cosine theta plus 1 equals 0? Those are your 2 issues you got to deal with. And you'll get your answers. And that's it. And that's not a theta. That should be a 0. Sorry. It's a 0. If this is 0, or if this is 0, the whole thing's 0, basically. So let's start with when is cosine 0? Well, we go from minus to plus here. So at 270. Also, we go from plus to minus here. So at 90. So at 90 and 270, cosine 0. So right here, we're going to have theta equals 90 or 270. And over here, back to algebra 1, take away 1 from both sides. Divide by 2. So cosine is negative 1/2. 1/2 is one of my special angles. Here's cosine. Here's 1/2. My reference angle is 60. It was a negative, I believe. So that's going to happen in the second quadrant or the third quadrant, because that's where cosine is negative. So we're going to draw it. A 60 reference angle in Q2 and Q3. So we're going to have that one, 120. And then also this one at 240. So this time we've got 4 answers again, 120, 240, 90, or 270. All 4 of those should satisfy this equation up top. So I think I'm going to stop there for today. Any comments, questions, or wisecracks before I hang up this call? That's correct. Yeah, just delta math. No Edmonton. What? Hallelujah. Okay. All right, you guys online, I'm going to end the call. And anything else before I do?